Yeah, yeah. Now it's okay. So now I
Okay.
can take questions and I will be answering them.
Okay.
It's better. Yeah. So okay. Okay. Anha is happy now. Let me ask for some questions from my end. Okay. So, what do you plan? What are your main streams you'll be planning on? Main themes of your research?
Okay. Main themes of research would be first of all tackling problems uh, on advanced nanotransistor uh, technologies such as black phosphorus, such as graphene. I mean, those
Mhm.
that are reported in the previous 4 or 5 years, I would say. Okay,
Okay.
handling simulation issues, modeling issues in these technologies because they are very much relevant right now. And since I have a background in working with some technology, so it would be a better option to start with these technologies
Mhm.
rather than stepping into going back to material science and uh, doing DFT calculations. So that uh, would not be my plan as of now.
Okay. So
Yeah.
for our audience, I guess, can you please give them an idea of how modeling is actually used in circuit design? I mean, how do we start from devices and how do we take it all the way to circuit design? About PDKs and what it means to actually use a model and why do we need models? Because I guess
Okay.
most of our viewers would not be from
Yeah.
this domain, so it would help them to understand why modeling is important.
Okay. For example, if you want to design any circuit, okay, let's say we are talking about an IC chip. Okay, people in companies like Intel and Texas Instruments, etc. They do these designs regularly. And if such a design is to be carried out, it is not going to be done right away on a semiconductor wafer. It is to be first of all done on a computer simulator where you actually use device models to do a first pass design suitable to your application, of course. Only then, once it passes those uh, basic benchmarks, only then it can go ahead to a foundry where it can be actually done, which it can be actually fabricated on a piece of
Yep.
semiconductor wafer. So this process, it involves various steps. The model development, you have to first of all understand the operating physics of the device that you're talking about, that you're going to put into your application. And
Mhm.
then based on that, you have to do a lot of calculations in terms of, let's say, how various charges are calculated, how current is flowing within the device, how various capacitances arise within the device, and then putting all of these things together in the form of a model code. And then that model code is used in some another platform, which is known as a PDK, process design kit. So it's a very stepwise and a very streamlined process where various verticals or departments get together, such as model developers, testing engineers, people who do measurements, and a team that does characterization. So all of them get together, and eventually uh, this process of model development gets complete.
Mm. So I guess Anha has a question. Have you ever tried your hands with heterostructures like graphene sandwich with 2D systems like MOS2 or MOS2?
Um,
Okay.
so with
So MOS2, I
yeah.
guess black phosphorus, right?
Yeah, so transition metal dichalcogenides. So with regard to fabricating them, as I said, that I have worked with only the theoretical part, so not the fabrication. I'm not an experimentalist, but in future I do plan to do this because, as I said, we have a thin film fabrication facility in our department where we can do MOS2 as well as other inorganic materials, so, such as zinc oxide, etc. Even not sure if we can do graphene, but MOS2 definitely, yeah.
Okay. So what is the status of interdisciplinary working in NIT Srinagar? I mean, how closely do you work with other departments?
Honestly, we have just taken off, so it's going to take a while before we start interacting with other departments. Things have been a little slow, but there is
Okay.
hope that things will pick up soon.
Okay. So what are other people working on in electronics, in
So
electrical?
the department itself specializes in various streams such as wireless communications. People work on, I think, machine learning, and some of the faculty have interests in doing image processing for biomedical applications. So these are some areas that our department has specialized in. Uh, as far as I am concerned, I am a purely microelectronics person. My interests are compact models for industry standardization. I do a little bit of circuit design, a little bit of characterization, and in future maybe fabrication. Yeah.
Okay. Uh, I don't see any more questions coming up, so I guess
Okay.
I'll have to go on. I'll still continue with my own questions. So how many students do you have right now?
Oh, it's a very young group as we speak. It's, I think, only two master students and four or five BTech 8th semester students. So they are very uh, active. They want to do research based projects. So, but in future, maybe this summer, we'll be having some of these PhD students join the group.
Okay, what about working with other universities like IIT Kanpur, your alma mater? So what are your
So,
plans? Do you plan to maybe send some students here for internships or maybe some other institutes?
so yes, of course, when we talk about research, a lot of collaboration has to go if we want to make something, if we want to contribute something meaningful to the table. So yes, IIT, not just IIT Kanpur, there are various institutes in India that really encourage collaboration and joint development, with regard to academic research. So yes, that is always a good option.
Okay, Anha has another question. Dr. Amir, how do you see nanostructure transport studies? It's novel, and do our students have a future in it with the help of physics?
Yes, why not? Definitely. So let's talk about how transport in these nano transit, or I would say transistors, was. It was purely drift diffusive. So right now you have this ballistic transport being seen in nearly ballistic transport being witnessed in uh, advanced technology nodes. So there is
Mhm.
definitely a lot of scope in this area. Okay, when you talk about nanostructure transport studies, and yes, it involves a lot of physics. Yeah, no doubt about that. So there is a lot of physics that goes behind
So
the
I guess the question is, do students have a scope in this? I mean, what are the future
yes.
future prospects of working in this?
I would say there are definitely future prospects, because when we talk about academic research does have a bearing on what on the industry. So industry people always are uh, in connection with academic institutes to sort out their problems, if whatever problems they have. So even this, as far as I understanding transport in nanostructures, it has its significance and can be used by uh, these semiconductor vendors and fabrication, these foundries. Why not?
Okay, and we have a question from Saeed Basit Masoodi. He asks, what role does quantum mechanics have to play in electronics? And should an electronics student go for research in fields like quantum entanglement, etc.? If yes, what are the opportunities and what is the scope?
Yes, there is a so really let me tell you that modern day transistors incorporate a lot of quantum physics. So when we talk
Exactly. I
about
mean,
10, right?
not a lot of, I guess everything is
Yeah,
just quantum physics these
yes,
days.
yes.
3 nanometer nodes, 5 nanometer nodes, you
So,
can't do classical
so
now.
the, yes, so you don't have classical physics operating at these channel lengths of 3 nanometers or 7 nanometers. So you definitely have to invoke physics that belong to the realm of quantum nature. So with regard to quantum entanglements, yeah, so those are definitely core physics areas that I don't specialize in, but definitely there are opportunities in that area. So I'm not one.
I'll add to that, Saeed. Yeah, I'll add to that. Then, see, when your structures become so small that the device dimensions itself is like the order of
Comparable.
wavelengths of of the electrons, then you can't
Mhm.
use classical anymore. If your device structure is something like 2 to 3 nanometers, then no more classical. It won't work. It all breaks down. So you have to use pure quantum-based methods. Okay, another question from Anha. Please tell us something about R&D at Intel, IBM, Samsung, and Global Foundries. Our students have no idea about opportunities in these corporations.
Okay, so it's a very good question because first of all, students need to be aware of what is there in, I mean, what lies in store for them when you talk about the industry, for example. So yes, there is a lot of scope or a lot of opportunities in such players such as Intel, IBM, Samsung. They are always looking for very bright PhD students or master's level students to carry out their routine projects in terms of device fabrication, modeling, and simulation. So yeah,
And
we
they've
need
recently
to.
started opening up new job profiles in India. Like Intel recently opened compact modeling, which was never there in
Yes,
Bangalore,
so
and
in
they're actively
Bangalore,
hiring for compact modeling in Bangalore.
yeah,
And
not
similarly,
only
Global
this,
Foundries, I guess, is also quite actively hiring these days, particularly masters and PhD students.
in fact, not just in India, they're also hiring globally. So if you,
Yes.
let's say, if you're a PhD, if you do your PhD from a reputed institute, definitely you will have the credentials to apply for posts globally.
Yep.
So
Yep.
yeah.
So, any more questions? Okay, let me ask you something else. Mm, Tell us in general, tell us about NIT Srinagar. It's been a year now. So, how do you feel?
Oh, it
How does
hasn't
it
been
feel
a.
to transition from a PhD student to a professor?
So from a PhD student, there was one more step, a postdoctoral fellow. As a
Yeah,
postdoctoral,
exactly.
there was more
Uh,
of freedom. There is more freedom definitely than a PhD student, and you get more responsibility in terms of mentoring PhD students. So once you are a
mhm.
postdoc, and once you're a faculty, so you have additional responsibilities. You have to manage between courses. You have to write proposals. You have to work towards establishment of your research group. So the workload automatically, exponentially increases once you are into academia in comparison to once we are doing our PhDs. What we usually think that okay, we are the most busiest people. We work around the clock in labs, publish papers, but that's not how it is. I mean, once you are a faculty, you realize that okay, that was the golden period once you were a student. Yeah.
Yeah. Yeah. I have one more question. Can you talk about proposals? What are the key things you should write when you're writing a proposal? And
Okay.
why? I guess most of the PhD students don't really care about proposals because in India there's not a culture of having your own funded projects. But there are
Mhm.
some projects like Inspire, and I guess there are a few more which require you to write your own proposals. So can you talk about briefly talk about what is important while writing proposals and what can be
So
some
I
good
think
points to
most
consider?
important thing is to identify who the funding agency is and
Mhm.
what kind of deliverables are we talking about. So if the
Yeah.
deliverables are something that might interest the funding agency, then the proposal has a very good chance of going through. Otherwise, it often people uh, don't realize that sometimes even theoretical research or uh, some kind of academic study can be a good proposal, but then it has to be applied under a suitable agency. Instead, if you're talking about, for example, an organization like DITY, DEITY, so they're looking for more prototype deliverables. So in that case, the research is not just study; it has to be in the form of a
Some
hardware.
output,
Yeah.
something tangible. I guess we've lost Dr. Amir. Let's wait for him to come back. Okay. Yeah, I guess he got disconnected
Yeah, there was a disruption in
for
the
some
internet.
reason.
Yeah.
Okay. So Anha has another question. Please tell us what corrections we have to make in our syllabus curriculum so as to enable our students for this field.
Mm, so what usually happens in
That's
institutes that syllabus
that's a
correction
hard
doesn't happen. Yeah, it doesn't happen right away. Like there is a formal board that sits together and then they plan on making updates. So and maybe it's usually it takes 2 to 3 years to update one set of uh, I would say course catalog.
Yeah, I
So
guess
but what
I'd say it's not that industry oriented. I mean, a lot
yeah,
of
yeah.
things we still study are not relevant anymore. So I guess it
Yes,
has to be
particularly
done in conjunction with the industry. I mean, you can't just do it independently. You have to take the
particularly
industry into account.
particularly what is being taught in the BTech level courses. Most of it is sorry, most of it is
It's okay.
obsolete. Yeah, I mean, a lot of the time is wasted in the first year, for example. I'm sure you must have gone through the
Mhm.
same. I mean, we do labs here and there from. I would say I'm not downplaying any department, but we have to ensure that the students remain focused from the first year itself, rather than doing labs in each and every other department in the first 2 or 3 semesters. I mean, a lot of important
I
time
guess
is wasted. Yeah.
I guess there's a trade-off between making students understand the basics and where to leave that. I mean, you need to have the first steps. Then I guess that's where we stop in all institutes, at least at the BTech level. I mean, there has to be a trade-off. You have to take some advanced topics, at least in BTech. That's what I've seen in IITs, at least. Students
Yes.
from final years taking 6 level courses.
Yeah.
In NITs, it's like it's a fixed curriculum.
Mhm.
At least you have some freedom in IITs. I'm not sure about other NITs, but NIT Srinagar, I can tell you it's very rigid. I mean, the system is quite rigid. The structure of the syllabus is quite rigid.
I think it's not just NIT Srinagar. I think it's more or less the NIT system that is not as
All
flexible
NITs.
as the IIT
Mm-hmm.
system. Yeah. Yeah. So there's more, I would say, traditional approach where they
Yeah,
try to follow the these age-old whatever is the course of the list of courses. So yeah, there needs to be more stronger handshake between the institute and maybe the corresponding industry branches. So that way the course should be updated.
okay. Anha has another question. What are the placement opportunities in this field? there is no good influx in Kashmir, but what can students do?
So in the field of, for example, nanoelectronics, there is a lot of scope, not just in India, I mean outside India. In Kashmir, let's say we definitely have a lot of talent in Kashmir. So there's no doubt about that. So I have even come across students, friends, I mean, who are very brainy and brilliant. All that is to be done is to give the students a proper direction so that they can maximize from the opportunities that are given to them. So I mean, it's a very uh, I mean, I was pleased to see that I think all IITs have a decent presence of uh, Kashmiri students. So that is, I would say, we are going in the right direction. Not just in my field of research. I'm talking about research in general, research and academics in general. Maybe in medical science or in physical sciences or engineering or whatever. So so year after year, you see more and more Kashmiri students making their presence in IITs and such institutes. That's a good thing. And we need to be more proactive. For example, this page has been doing a really good service to the Kashmiri youngsters in terms of educating or making them aware of what are the various opportunities if this area is tried, this research and all academics, all of it is tried. There is more that students can do in this because there is definitely talent. So yeah.
Okay. Any other questions from the audience? Guess. Yeah, I guess that's it. So I'd say this should be, yeah. Okay. So let's thank Dr. Amir Ehsan for this Webex 10, which was done in
Thank you.
association with the JKScientists. And we should thank the team at JKScientists, particularly Anha. She's been quite
Yeah,
proactive.
she has. Yeah.
uh, Thank you, Anha, for organizing all this. Okay, another question from Anha. Please tell us about some classic textbooks we must follow in this course. She's not leaving us
Okay.
this early. Yeah. There's a panel shootout. Okay, your voice is not clear. It's okay. Uh, so I guess that's it. So we'll end this session now. Thank you, Amir. Thank you, Anha. Thank you,
Thank
everyone, for
you.
watching.
Thank you,
Bye.
everyone. Yeah, thank you for this opportunity. Take care.
Bye.
So I think we are live. So Athisham, thank you for the introduction that you did a short while ago. I'm sorry we are not able to connect for some reason. To start with, I would like to thank the Kosher Scientist Forum for giving me this opportunity to host a Webex or a Facebook Live session. In particular, Anha Bhatt for making this a very live, very vibrant forum. I remember it was not such an active forum a few years ago, but now it has completely changed for good. Uh, so today's session is about some introduction about semiconductor device modeling and characterization activities that we are in the process of initiating at NIT Srinagar. Myself, my name is Sheikh Amir. I am a faculty in the Department of Electronics and Communication Engineering at NIT Srinagar. Prior to joining NIT Srinagar, I was a postdoctoral fellow at New York University. Before that, I was a PhD student at IIT Kanpur. I received my PhD in 2017, towards the end of 2017, from Nanolab, and Professor Yogesh Singh Chauhan was my PhD supervisor. My specialization, I would say, my background is nanoelectronic devices, primarily the modeling side. I'm not an experimentalist, prima facie, but yeah, I am trying to move towards that side as well. So the topic for today's session is semiconductor device modeling. So just as a starter, let me start with what we mean by semiconductors. Semiconductors are nothing but a group of materials whose conductance or conductivity falls within the range of that of insulators and full conductors. But they have this very interesting property associated with them that they can change this conductance by when certain operations are carried out on them. For example, we dope them and it suddenly changes the nature of the device from being a nearly insulator at intrinsic levels to maybe something like an N type or a P type once you dope them. And therefore, they are suitable candidates for being used as channel materials in transistors. Now, what are transistors? Transistors are something that are pervasively used in the electronics industry right now. In fact, all of us are surrounded by these transistors or semiconductor devices, to keep them general. For example, you have laptops, you have smartphones. So I would say you are literally surrounded by these devices, maybe if not billions, but millions of them in the form of your IC chips and laptops and smartphones. So the thing is that a lot of physics goes in making these devices operational and making the maximum out of their, I would say, performance. So the end-to-end process is that you have a material, you use it in the form of, I would say, a transistor, put few transistors or some such devices together in the form of a circuit, and then use it to a certain application in a system. Now, I would say that over the past few decades, I would say, so there has been a lot of scaling or cutting down in the dimension of these transistors in order to push the performances of these devices in terms of speed, in terms of area that they're occupying on the chip, the power consumption, etc. So, for example, you have these FinFETs, you have these ultra thin body silicon on insulators, etc. These are the modern, latest, state of the art technologies that make it possible to extract the maximum from these transistors at nanoscale. The problem is that we have kind of reached a stage where I would say the performance has kind of reached an impasse. I mean, you cannot expect more from these materials. For example, silicon has been there in the industry for nearly 50 years or so, and now people are looking for alternate materials such as 3,5 groups, such as gallium arsenide, gallium nitride. Then you have these latest two-dimensional channel materials such as graphene, such as carbon nanotubes. You have black phosphorus, and then transition metal dichalcogenides like molybdenum disulfide, etc. So in order to maximize the performance of devices based on these technologies, these material technologies. So let me give an introduction as to where people like me get in. I mean, I am a modeling person by my background, my specialization. So, what is device modeling? So, imagine that you are a circuit designer, and what you would usually do is you'll collect a bunch of these transistors and go to your lab and put them together on a breadboard or a PCB for that matter, and make the connections based on whatever circuit you are drawing. You'll have some resistors, you'll have some capacitors, and whatnot. And then you'll check the characteristics of the circuit on using an oscilloscope, right? Uh, the important thing is that if the same process is to be carried out in an industry for making a state-of-the-art IC, uh, this is not how it would be done. So the general procedure involves something which is more sophisticated. Like people would go for something called a computer-aided design, a CAD tool, in order to do the design first using a computer simulator, and then eventually it would be taped out on an IC in a foundry where it would be fabricated. Because there is nothing like an iterative process. Yes, of course, there is iteration in terms of making the first pass design, but uh, it's not like you first fabricate and then update the design and then again fabricate. That involves a lot of money and cost. So that's not a viable option. That's where these computer-aided design tools come in. I mean, and they are only as good as the models that they have for these nanoscale devices. Now, so it's these models that I'm talking about. For example, you have these MOSFETs, transistors. There has to be an accurate and a robust, I would say, a very efficient and a fast model in order to put them into a circuit environment. I mean, so that you can design very accurate circuit applications. And in order to be a very good model, for your model to be very good and efficient and accurate, you need to have a thorough physical background of that model of the device and how these devices are operating, how are the electrostatics that are taking place, what about the mode of transport that carriers are going to follow. Is it tunneling? Is it ballistic transport? Is it quasi-ballistic? Or is it normal drift diffusive? And all this technical jargon, I would say, would get in. So as far as NIT Srinagar is concerned, I am a fresh faculty there. I'm a new joinee, and ours is a very young group. It's only as strong as, I think, I would say, two master students and a few bachelor students in their final semester who are interested in doing research-based projects. Hopefully, we'll be having a couple of maybe more PhD students join this summer, and we are also in the process of finishing a few or writing a few proposals to government agencies such as DST, SARP, and there is high likelihood that we might also end up getting projects from the industry in carrying out model standardization or implementation in commercial simulators. So I think that is all about my side. Yes, we do have some facilities in NIT Srinagar with regard to thin film transistor fabrication. A colleague of mine, Professor Najibuddin, has some very good setup with, in the department. We have some very nice sputtering tools. We have some characterization setup as well, but I mean, within India, we can use facilities from various IITs, IISc. I think they are much more sophisticated and state of the art with regard to characterization of these devices. So I think I we can take some questions from the audience if there are any. Okay, what motivated me to work on gallium nitride? So there was nothing like motivation. There was a need when I joined IIT Kanpur. At that time, this was a new thing, gallium nitride, by virtue of its very impressive material properties, high band gap, very nice two-dimensional electron gas mobility, and other properties. It was going to be a very big thing, next big thing in power electronics and RF technology. There's a body called the Compact Model Coalition. What they do is that they standardize these models for these semiconductor devices, and they were looking for a new model that could be incorporated in these commercial tools, so that this design can be taken out. SCAD design can be done very efficiently. So my supervisor, I mean, he advised me to take a look on this project and join. We were doing this project in collaboration with another faculty from a university in California. So it was a very fruitful experience. Right now, I mean, the good thing is that it finally got standardized, and in fact, some of the modern commercial simulators have already incorporated that device model, along with MIT also. MIT was the other team to work on this. But I think it's still, I think gallium nitride will have a lot to offer for the next 5 to 10 years. Gas for future nano devices, I would say with gallium nitride has more or less surpassed this one, gallium arsenide, with regard to electronic applications. I think, but then these quantum well technology and optoelectronic applications, gallium arsenide is still a good one because it's still a mature technology. It's as I think 30 years or more old, whereas gallium nitride is relatively new. So we also have to take a look at how mature the technology is. We cannot just like that displace one technology. It's very difficult to, for example, replace silicon. Why? Because it's a very mature technology. Same is the case with gas and gas. GAN has issues in fabrication. Yes, it has not yet been standardized. Correct. Yeah. So that is what I was talking about. So you need to streamline the recipe. So it's not yet done in gallium nitride. I'm talking about more from the academic side. Although in the industry, they definitely have far more superior, sophisticated ways to work with GAN technology. That's why they're putting in a lot of money in GAN instead of other material systems. I'm not able to add Ahtisham for some reason. Okay. Just a second. There's one question on IoT and artificial intelligence. So yeah, you're right. Maybe NIT Srinagar is far behind in comparison to its other contemporaries in India. So yeah, I don't specialize in artificial intelligence or IoT. Hopefully things will pick up. Facilities will NIT Srinagar over the next 5 to 10 years in terms of characterization and fabrication. Okay. Yeah. So establishing facilities in characterization and fabrication is not easy. Okay. First of all, otherwise you would have seen such facilities in all IITs, right? But they don't have that. Apart from IIT Bombay or IIT, sorry, IIT Bangalore, I don't see many other IITs having very good fabs. Similarly, characterization setup. It takes crores and crores of rupees in establishing a very nice characterization setup. So it all depends on what sort of funding we have in order to establish a lab. And if NIT Srinagar is fortunate enough to get some good projects, then maybe we may have some exciting things to do in the future with regard to characterization and fabrication. I'm not able to add. Atishan tried. I think I can read the questions like this. It's okay. I can continue. We can continue like this. Yes, yes. So yeah, that is what I was talking about. There is this INUP program. Yeah, definitely all institutes can benefit from, because I think Bombay and Bangalore, we have some very nice state-of-the-art facilities there, and they do encourage people from all over the country to use those facilities. So should we continue like this, or do we need to start another live video? Not sure. Okay, let's continue. Let's continue like this. Quantum computing, I'm not sure if there is, although there are uh, commercial simulators for doing regular device simulations, such as you have Synopsys Centaurus, you have Silvaco. Shortly, there may be some other tools such as Global TCAD, etc. So we can do all sorts of things with device simulators. I'm not sure if there is any quantum computing simulator over there. Okay, so this is a very interesting question. Why India does not have any VLSI industries, although raw material is present in abundance. So somebody once said that in order to understand if a country is developed or not, take a look at what kind of semiconductor fabs they have. So that is one way to see where you stand in terms of development. So India unfortunately does not have any good fabs, and it may be related to, I would say, funding, and also the weather and all conditions also play their role. Okay, how can students apply under, okay, for INUP? So I think we can jointly write proposals to the coordinators of INUP, and definitely we can take it from there, take it further. So if there are any students who are willing to do some joint project with regard to fabrication, yes, it would be a very nice venture. We can try it out. NIT Srinagar has required multiple students, RF circuit design, and planning anything in that direction. So I think there's only this advanced design system tool for RF circuit design, and that's pretty much used everywhere in the industry for RF. So my plan with regard to RF circuit design I'm not going into that direction for now because mm, it would need a lot of handshake between uh, the institute and the industry, and uh, so maybe that can be done in the future, but not for now. Sham, can you add me or as or can okay, fabrication facilities are simple TC and RF sputtering to grow thin films that we have in NIT Srinagar. Like we can do fabrication of inorganic thin films such as zinc oxide or these 2D transition metal with dicalcogenides like MOS2, molybdenum disulfide, etc. So these are the transistors that we can make out of these thin films. But making a full-fledged fab is a huge project in itself and will take considerable amount of time in reaching that stage. I'm not sure if I have to send him a request or if Sham is supposed to send me the request. Either way, I think we should continue like this. So I recently had the fortune of interacting with some students from Kashmir University who are in this area of research. I was very glad to see that they were very positive about pursuing higher studies in this area. Um, in fact, I'm very open to providing any sort of guidance or help as far as I mean, it's well within my comfort zone. It would be my pleasure to help students or even do some kind of short internships or even do a full-fledged project also. Interface of biotechnology and electronics in the okay, it's a very interesting thing. Yeah, for example, I'll tell you, we as far as I have come across, so biosensors are very interesting uh, technology that people are really interested in. You'll see a lot of papers in latest IEEE journals having content on biosensors using, for example, gallium nitride or other device technologies. So this has its applications in medical field as well as day-to-day life. So yeah, it's a very promising field, biosensors. Okay, basic simulation tools used to train students at master's level. So, for example, we want to carry out any device simulation. So, for that, we have the well-known uh, synopsis to carry out regular device simulations. And we have some circuit simulation tools as well, like the one by Cadence, which has Spectre as its circuit simulator. So, in IT, we do have programs to to take students to these labs which have these setups so they can kind of learn the basics of device simulation, how to carry out circuit simulation using these cadence tools in more or less realistic environments. And even when we have this provision of sending those designed circuit layouts to this SCL, which is the Semiconductor Lab in Chandigarh. So there is a tie-up between NIT Srinagar and SCL, so that the designed circuits can be taped out at SCL using their 180 nanometer technology. So, any other questions? Okay, material level, no, for nothing for now, like ab initio and DFT based analysis, no. That is more towards an interdisciplinary kind of research, something that maybe we plan to do in future, but not now. Yeah, thank you very much, Anna. Yeah, it's a very nice gesture on your part. It would be really nice if we can do something jointly. So before we have any other questions, let me once again summarize for the audience that joined a little later that my focus is on in advanced nanotransistors, doing their theoretical modeling. I'm a theoretical person, not an experimentalist, and my interests are in developing compact models for these advanced device technologies such as FinFETs, such as UTB, SOI. Recently, you must have heard about these negative capacitance transistors or two-dimensional FETs based on graphene, black phosphorus, etc. There are a lot of challenges that we as model developers have to face because there is new physics every time you have a new technology. So all of that has to be considered before we put things together in the form of a model code that can be used for carrying out your normal self-circuit simulation and design. So it's a pretty challenging and exciting field. Okay,